Hello, very good morning. Am I audible to everyone?
Very good morning, sir. How are you, sir?
Yeah. So can you see the screen now?
Yes, sure.
Okay.
It's visible.
Yeah, sure. So in last lecture,
How are you, sir?
I am fine. About you?
Fine.
That's great. So, okay. One more thing that already I think so you have got your PSPD mid-sem in mid-1 marks. Have you got the mid-1 marks or not?
Is it released?
Yeah, already have checked or already have assessed your answer sheets. So that's I'm asking. Have you got your marks of mid-1 or not?
Okay, let me check in the portal.
Okay, no problem, no problem. You can check it later. Okay, so just we are starting out my topics that we have to teach now. So if you remember in the last lecture, we have discussed about the distribution system, AC and DC, and we have compared both one. Okay, so now today I'll go with the numerical problem on different types. So it's just you can see the screen that already we have discussed these topics. So I'm highlighting. Just give me some time. Yeah. So this topic, development of a decision system, that we've discussed. If you remember, what is the role of decision plan that I've discussed? What is the meaning of transient and decision system that we've discussed? Types of distribution system arrangement, that also I have discussed primary and secondary. We have discussed a little bit and we have started this topic. Clear? So just I'm going further more that if you remember this topic I've discussed already. What is I have just left in the last lecture here, that what is the requirement of a distribution system? Okay. So we have discussed three topics, that whenever we are designing a distribution system, at that time, what is the role of good distribution system? So if I'm talking about a good distribution system, it means they must be capable the three parameter. Number one, proper voltage. Number two, ability of power on demand. Number three, reliability. Now, what is the meaning of proper voltage? What is the meaning of ability of power on demand? What is the meaning of reliability? So first of all, what is the meaning of proper voltage? So one important requirement of a distribution system is that voltage variations and consumers terminal should be as low as possible. Suppose just I'm giving the example for Gujarat. So PGVCL is a distributor company and just we are consumers. Now, consumers are getting the supply voltage, and that voltage at every hour is fluctuating. Sometimes it is 215 volt for single phase supply. It is 215 volt. Sometimes it's 210 volt. Sometimes it's 198 volt. So if at every hour fluctuations is going on, so that's not a good parameter. Means ultimately your voltage regulation is always changing with respect to load. Of course, because no company can control the switching on and switching off of the appliances, clear, at any consumer side. So of course, the proper voltage must be provided to all consumers. It means voltage fluctuations must be within a permissible range. That's meaning of proper voltage. So one important requirement of a distribution system is that voltage variations at consumers terminals should be as low as possible. The change in voltage are generally caused due to the variation of load on the system, because consumers means consumers may be for the industrial load, that may be consumers maybe or residential buildings, maybe of means municipal corporations loads. So ultimately consumers means the load system, or we can say the buildings where we are residing, or any industrial loads are there. So ultimately, whenever we are switching on and switching off any appliances, it means we are changing the load. So that load variation of course will change the voltage at the consumer side. Clear? That is called terminal voltage will change. So the thing is that low voltage causes low loss of revenue, because if the voltage regulation will be allowed in a person's range, but if the range is increasing, means your voltage regulation is increasing, it means that it causes losses of revenue, inefficient lighting, and possible burning out of motors if voltage fluctuations very in high rate. At that time, possible burning out of the motors also. So high voltage causes lamps to burn out permanently and may cause failure of other appliances. So that's why any distributor company must keep in mind that the proper voltage must be provided to the consumer side, and voltage regulation must be within a permissible limit. So that's the parameter of good distribution system. Next one. So already I've said that the voltage variation, what is the limit? So we can say, for if I'm talking about the low value consumers, that is called low voltage consumers, that is called residential buildings. So we can say plus minus 10%. If I'm going for the high voltage consumer, that is called for industrial load or any load that is working for the 11 kV. So that is always plus minus 5% it is required. So I've given an example, you can see on the screen. If the declared voltage is 230 volt, declared means that is rated voltage. If rated voltage is 230 volt, and if I'm taking plus minus 6% range, then the highest voltage of consumers should not exceed 244 volt, and the less, that is called 216 volt. Nothing, just what I've done, I've just taken the voltage of 230 volt, the 6%. So just plus 6% and minus 6%. Clear? That's your, we can say, voltage selection. How can you select the voltage for a consumer level or distribution system? Now, what is the meaning of ability of power on demand? Also, I've discussed this topic in the last lecture. If you remember, this time reminding again. Ability of power on demand means, suppose we are having one function, like just you can see on already you have visited actually also you visited in Vibrant Gujarat. Yes or no? Have you visited to Vibrant Gujarat? Are you here, Ashilo?
What's your question?
I'm asking, already you have visited to Vibrant Gujarat, am I right?
Yes,
You
yes,
have gone to,
yes,
you have
sir.
gone to Ahmedabad, am I right? So actually Vibrant Gujarat is, we
Yes,
can, is every year it's happening. Listen carefully. What I'm just relating this topic, ability of power on demand, from that event, because Vibrant Gujarat is the event of Gujarat, but that is happening every year. Clear. So this is already fixed time that this event will be in the month of December, January, or February, approximately. So ultimately, now suppose I'm saying Vibrant Gujarat is happening or is already is going on. Now, of course, you know very well that Vibrant Gujarat is happening on a large scale. So that's why the load demand will be very, very high only for that for the 14 days, for the 2 week, or for the 1 week. Clear. So what's going on? So first of all, that ability of power on demand, it's meaning that what is the meaning of this line? It, it's the meaning that if any consumer is demanding on surplus power at urgent level, so the distributed company must provide that power at any cost because consumer is already capable to pay that surplus cost. He will pay, or of course, he will pay the extra amount because he is asking some surplus power in emergency conditions. So that's why any distribution company, if the company is capable to provide the power, surplus power on demand, at that time, this is also sign of good distribution system. And the third one, that is called reliability. So reliability, of course, if we are talking about the consumer side, so of course, if we are selling a power to any consumers, that must be reliable, that must be security purpose, it must be good, clear. So that's I've content some topics that is called 3 parameters we have to take care. Number 1, proper voltage. Number 2, that is called reliability, and number 3, we can say ability of power on demand. Clear. Now we've discussed about the AC distribution. If you remember, we have already discussed in the last lecture, that is called what is the meaning of primary distribution system, what is the meaning of secondary distribution system. Primary have already discussed. I have given this diagram. Secondary also have discussed. Primary, that is work actually primary is basically working on the 11 kV line. Clear. 11 kV, 6.6 kV, and 3.3 kV. These three are the voltages which is occurring for the primary side. Primary means we are talking about the large industrial loads. Secondly, that's I'm talking about the residential buildings. So of course, we are talking about the 3-phase 4-wire system that is called 400 volt, or single phase system that is called 230 volt. So we have discussed about this one. Next, I have discussed about the DC distribution. What is the meaning of DC distribution? So I've already given some point that it is a common knowledge that electrical power is almost exclusively generated, transmitted, and distributed as AC. But of course, for certain applications, we are also dealing with the DC services, means DC supplies there also. For example, if we are running a variable DC motor, or we can say any DC motors for the variable speed machinery, so ultimately we have to provide DC supply. So DC supply or DC distribution is already existing, but that is on the demand first of all. But most of all in India, most of all we are working for the AC distribution. Clear. So if you remember, we've discussed about the 2-wire DC system, 3-wire DC system. Already we've discussed. If you remember, we have also given a comparison between all wires. This topic already discussed. Clear. So I'm just giving a review for the last lab that already discussed in the last lecture. That what is the meaning of 2-wire system? What is the meaning 3-wire DC system? What is the meaning single phase 2-wire system, 3-phase 3-wire system, and 3-phase 4-wire system? So these 5 types of system we have compared already in terms of resistance, in terms of area. We have also given a comparison between overhead lines and cables we have discussed. And after that, we have discussed about the Kelvin's law, if you remember. So we have discussed about the Kelvin's law. What is the meaning of Kelvin's law? How can you find the economical conductor area? We have given this derivation consisting of C1, C2 cost. Clear. And after that, we have discussed about the modified Kelvin's law, limitations of Kelvin's law that we have discussed. Clear. This numerical problem already I have done. 3 problems we have done, if you remember. So number 1, that is already I have done. Number 2, that I've done already. Clear. And third one, in third one we have already given that. In third one, what we have given some specification that in terms of we have given that particularly we have given some density. Density means we have to find the weight of the line. Then with that density we can find the total loss of the line. So this is the problem that I've done. All 3 problems we have done. Clear. Then what is the designing of distribution system? How can you design? So we have discussed that whenever we are talking about the primary distribution system consisting of feeders that deliver power from distribution substation to distribution transformer. So what is the primary distribution system actually? The primary distribution system is the part of electrical distribution system between the distribution substation and distribution transformer. Because if I'm talking about the primary, ultimately what is the primary distribution system? Means that is stepping down the voltage of 66 kV or 33 kV to 11 kV or 6.6 kV or 3.3 kV. So whenever I'm talking about the line, that is called feeder actually. In primary distribution system, that is called feeder. So primary feeders or distant feeders are dealing with stepping down the voltage with the help of a step down transformer, that is called distant transformer. Clear? They're stepping down the voltage of 66 kV or 33 kV to 11 kV or 6.6 kV or 3.3 kV. So these feeders include the primary feeder mains and the main feeder, usually a three-phase 4-wire circuit we are using for this one, having some branches and laterals, which can be either three-phase or single-phase circuit. The primary feeders main is usually sectionalized by reclosing devices like your, you can say relay something in there, circuit breakers is there, and we can say bus bar system is there. So of course we are making some sectionalizing system of the primary feeder so that if there is any fault, we can use some parallel feeder or we can sectionalize the system of the faulty system to the healthy system. Clear? When we are talking about the design of primary distribution system, so what things we have to keep in mind? Design primary distribution system depends upon the following factor, that is called number 1, choice of voltage, number 2, choice of conductor size, number 3, choice of type of system, and number 4, voltage drop calculation. So first of all, choice of voltage, that topic we have discussed, because choice of voltage depends. Okay, so the choice of voltage already we discussed in the first unit. If you remember, that choice of voltage depends on two parameters. That number 1, which amount of power is transmitted or distributed in the feeder. First one, that is to power amount in megawatt or whatever the power in kilowatt you are transferring in the line. Second, what is the distance of the line? So choice of voltage depends only two parameter. Number 1, that is called power transmitted to the line, transmitted or we can say distributed. Both are the similar thing. Number 2, what's the distance of the line? Clear? Between two substations, that is also two substations, or we can say substation to a consumer side. Clear? Number 2, that choice of conductor size. Already I have discussed this topic in Kelvin's law, if you remember. So Kelvin's law is the rule to find a conductor size, or we can say optimal area. Next, choice of type of system. So if you remember, we have discussed 3 types of system. Number 1, radial system. Number 2, that is called parallel feeder system. Number 3, that is called grid system or network system or interconnected system. Now the thing is that you have to understand in among these 3, which one must be used in different distribution system. Clear? Maybe you are using for some distribution system, you are going for the urban areas like within the Rajkot city. You are designing some distribution system for the we can say rural area in terms of nearby the village of the Rajkot city. Clear? So it depends that which type of system you are using, radial system, you are using parallel feeder system, or you are using that is called internet system. So which system you used for the which type of area, because it depends on the load condition. Actually, choice of type of system depends on 3 parameters. Number 1, what is the load demand? Means what is the total load of the consumer side? Number 1. Number 2, what is the area of the consumer side? Which type of area you are having there? Number 3, that what is the reliability, or we can say what is the consistency of the consumer side? Clear? Suppose if I'm talking about the, suppose we are talking about the industrial load. Industrial load means, of course, industry, they require a power at any cost. They require a power because we cannot shut down the power at that site. So of course we will provide either parallel feeder or network feeder, that is called interconnected feeder, because you know very well, already I've discussed the classes, that radial system, the system which is, we can say in radial system, we are providing a power only in one direction without any parallel feeder, without any interconnected system. So ultimately, if there is any fault in the radial system, of course, because the power flow is only one direction, if there is any fault, power flow will be stopped. So of course, so this system is not reliable, means ultimately this system not secure for the heavy load side, or we can say for the industrial load consumer. That's not suitable. So of course, so that's I'm saying choice of type of system depends on three parameters. Number one, what is the load demand of the consumers? Number two, what is the area of the consumer side? Number three, what is the sensitivity or we can say security requirement of the consumer side? Next one, voltage drop calculation. So how can you go for the voltage drop calculation? Of course, if we are talking about the relay system, then voltage drop will be different. If we are talking about the parallel feeder, the voltage drop will be different. If we are talking about the interconnect system, voltage drop will be different. So already three topics, choice of voltage we have discussed already. Choice of conductor size, we have discussed Kelvin's law already. Choice of type of system, that is called radial system or parallel feeder system or interconnect system. We have already discussed all three system and which is advantageous for which type of system. So all three topics we have discussed already. Now thing is that voltage drop calculation that we didn't discuss. Clear? If you remember, I don't know that already you have read SQL or not, but in EPS1 you have solved some numerical. I'm just giving a small picture I'm drawing here. Hopefully you can remember. I will solve, but this time I'm giving an idea for that. And suppose this is your A side, and I'm providing 230 volt here, and we are having this is radial system. It's B, C, and D and E. There are some consumers load terminals are there. Clear? B, C, D, E, and they're having some distance of 500 meter, 100 meter, 200 meter, and 300 meter. So such numericals you have find already you have solved, yes or no, in EPS1?
Yes, sir. Yeah. We have
Because
them.
this is the part of EPS1. Already we discussed this type of numerical. Already I will discuss here, don't worry, but just I'm trying to speak first of all that thing you must know that such numericals already we've discussed. Actually, these numericals are coming in this category. Which one? Voltage drop calculation. If you remember, in these numericals you are finding the section current, the section voltage drop, and the voltage at each point, that is called voltage at B, voltage at C, voltage at D. So such numericals you have already solved in EPS1 that I'm going to solve again. That is your topic of second unit, design of distance system. Okay. So already I've said choice of voltage. We have already said if we are talking about the primary feeder. So of course we have to take care in primary feeder means primary distance system. We have to take 3.3 kV, 6.6 kV, and 11 kV voltage. So choice of voltage depends upon the distance and amount of power to be transferred that already I've discussed. And the factors affecting choice of voltage are generally accepted standards, local regulations, physical relations with other power system, nearby and relative reliability. The percentage power loss and voltage drop for any given load and wire vary approximately as the square of voltage. That keep in mind that of course power loss and voltage drop will be varying for the different types of system already we discussed. But the most economical distance between substations and the number of substations in the system is a function between voltage. So what is the design recommendations are there? When we are talking about the design recommendations, so distance and substation design must be a combination of reliability and quality of power supply. Because if you are working as a design engineer, or we can say if you are working any electrical engineer in any power system plant or distribution system, at that time, if you are designing a distribution system arrangement, so it must be recommended that the system must be reliable and the quality of power supply must be with standard. Clear? Safety, of course, must be there. So that I'm just writing this line you can read here. Distribution substation design must be combination of reliability and quality of power supply, safety, economics, maintainability, and simplicity of operation and functionality. So the time is now 11 and Nesru is coming now. Okay. Second, safety of life and preservation of property are two most important factor in the design of substation, because when we are designing a substations, of course, safety of life will be a most important factor. Safety of life means safety of human beings, safety of animals, safety of all environmental effects. Codes must be followed and recommended practice that already, if you remember, I have given some IEEE or IEC code for presentations. Clear? So of course, every redistribution design system must follow some standard code in terms of IEEE or in terms of IEP. A variety of basic circuit arrangement are available for distribution system. So selection of the best system or combination of systems will depend upon the needs of the power supply process. What is the limitations or what is the some we can say working conditions that have to keep in mind? So following are the operating and design limits that should be considered in order to provide safe working condition. Number one, interrupting devices in terms of that is called relay circuit breaker must be able to function safely and properly under the most severe duty to which they may be exposed. Means suppose we are planning, suppose we are working on any CB or circuit breaker or any relay. Now we are already designing system, but the thing is that if that system, if that relay or circuit breaker or any interrupted devices or safety device is not working on the severe condition, or we can say or the other type of faulty condition, of course there is no need of such system. So accidental contact with energized conductors should be eliminated by means of enclosing the conductors, of course, with the help of any circuit breaker, relay system, or any bus bar that we can see what we can use here. Installing rotated barriers and interlocking system must be there. The substation should be designed so that maintenance work on the circuit and equipment can be accomplished with these circuits and equipment de-energized and grounded. Warning signs. आपने देखा होगा, already you have seen whenever you're going on substations, you have already seen some danger sign. Clear. So danger sign, the voltage rating sign, or something signs means for sign board must be at every substation where we are working for the high voltage. So warning signs would be installed on electrical equipment accessible to both qualified and unqualified personnel, so that any person which is qualified or unqualified both can get that sign, both can get the knowledge of that sign. So we have to draw some signs, or we have to draw some warning signs in such manner any person can read that sign, can understand the sign, so that the safety will be proper for the system. And that continuously I'm going for that number 5, that is called an adequate grounding system must be installed, of course, because grounding system of a substation, that's a very essential requirement for safe working. Emergency lights should be provided when necessary to protect against sudden lighting failure. Operating and maintenance personnel should be provided with complete operating and maintenance instructions, including wiring diagram, equipment ratings, and protect device settings. So in general, system costs increases with system reliability if component quality is equal. Of course, whenever we are talking about the high quality of components and whenever we are talking about the high security accessories, of course the system cost will be increasing. But we have to take care about the maximum reliability per unit investment can be achieved by proper applied voltage and well-designed components, because the security must be there. I know, because whenever we are using high security systems, or we can say whenever we are using maximum reliability conditions are there, or equipments we are purchasing for the high quality systems, so at that time the cost will be increasing. So no problem, but the maximum reliability per unit investment of cost, that must be analyzed and must be achieved by doing properly applied voltage or well-designed component. So just I've given one picture for understanding. You can see this picture. So this is your, you can say alive that already some signboards is there. So you can see what is the signboard, what is the meaning of signboard, what is and how is it working ultimately. So you can see the grounding system is also there, and some lining they have already saying on which you can, with this stand you can move inside the substations. They have given some particularly signing boards, they have given some lining systems also. So just I've given some single line diagram, that single line diagram of any system, that how it is working. So you can say this is supply line 1, supply line 2, disconnecting switch, that is called disclose, and that is called enclosed closing switch, switch number 1, switch number 2. It's your HV side breaker, because already I've said I'm saying HV side because I'm talking about primary distribution systems. So of course we are stepping down of 66 or 33 kV to 11 kV or 6.6 kV or 3.3 kV. So of course, whenever I'm talking about the incoming line, so incoming line consisting of 33 kV, 66 kV or more than that one. Clear? If I'm talking about the secondary side, that is called outgoing line must carry for 11 kV, 6.6 kV or 3.3 kV. Because just I am giving a single line diagram for any distribution system. It consists for the primary, it consists for the secondary also. Clear? So that you must keep in mind that how it is working first of all. So figure provides an example of the distribution substation single line diagram with 2 transformers, 2 supply lines and 2 sections at both the high voltage side and low voltage side. with a sectionalizing breaker at both HV and LV voltage. You can see this is your LV breaker and this is your LV breaker. So transformer number 1, transformer number 2. Already I said transformer number 1 and transformer 2 both are stepping down the voltage from 66 or 33 kV to 11 kV or 3.3 kV or 6.6 kV. That depends on your system of voltage and requirement of your consumers. Such an arrangement provides redundancy and reliability in case of any component failure by transferring the power supply from one section to another. Now what's going on? Already you can see we are having parallel two lines. We are having two parallel lines. So suppose if there is any one, if any in one line, if I'm getting any failure or fault, clear. So if any fault is occurring in the line 1, supply line 1, clear, of course we can use the supply line 2. So this is called parallel feeder system, where we can use the sectionalizing breaker with the help of supply 1, supply 2, line 1 or line 2. Clear. So this system, of course, the system cost will be increasing, of course, because if you are making a parallel system, it means the system cost will be increasing. But the second, on the other hand, reliability and security will be high in terms of consumer side. Now, what types of DC distributor I'm using first of all? So DC distributor can be classified as following. Number 1, that is called distributor at one end, distributor fed at both end, distributor feeder at the center, and that is called ring distributor. So this is your numerical problem I'm now discussing here first of all. So number 1, what is the meaning of distributor fed at one end? It means, what is the meaning of that? Means this is your power supply, this is your line or feeder, we can say. So at this feeder we are adding voltage at only one side. Now on the second side, or we can say on the line side, we are having some consumers. This is called feeder at distribution feed at one end, means we are feeding voltage at one end. What is second and both end? Means also we are providing some voltage VA at A, and we are providing some voltage at B point, that is called VB, clear. And meanwhile, or between this line, we are using some consumer side, that is called CDE. So this is called voltage feeding from the both end. This is called voltage feeding from one end. What is center? We can say now we are adding, just we are providing feeding point as center, that is called C point. We can say center, voltage center, and we are using some consumers either left side or right side. What is a ring distributor? Of course, ring means we are taking a ring system, or we can say integrated system, and we are providing power like that, and we are using this as a outer terminals, means your consumers will be here. So this is your ring system. So hopefully already I have said that this type of numerical you have already solved in EPS1. So this is your power, like A point I am feeding the power, at B point, at C point, at D point, and at E point I am taking some load terminals. Clear this like. So these are 4 types of power system, that is called number 1, voltage feeding at one end, voltage feeding from both end, voltage feeding at center, or voltage feeding from one end or two end, or we can say in terms of that is called integrated system or ring system. So these 4 types system will work together. Clear. We'll discuss some numerical problem that how can you solve and how can you find the voltage drop and voltage in each type of section. So starting from first one, that is called distributor fed at one end. So in this type, distributor is connected to the supply at one end and loads are tapped at different points along its length. The current in various sections of distributor away from the feeding point goes on decreasing. Of course, means what is the meaning of that? For example, suppose I'm providing some voltage here, that is called 230 voltage there. Clear. And if I'm making this sections voltage like that, so of course the voltage at B point, voltage C point, voltage at D point will be decreasing. Why? Because of course the voltage drop will be here. That's why. It's very easy question. That is called, if I'm saying this is your VB and it's your VA volt, and something I into R, I1 into R1 drop is there. What is R1? That is called resistance of line. What is I1? That is the current in the line from A to B. So what is the equation? Equation will be VB equal to voltage at B point, that is called BA minus I1 into R1. Similar, if I'm saying the voltage drop will be here, that is called I2R2. So what is the voltage at BC? Of course, BC, that is called VB minus I2R2, or we can say VA minus I1R1 minus I2R2. So thing is that the current, the voltage drop will be decreasing because that's why current will be also decreasing. From the figure, the current in section DE is less than the, just I'm giving examples here that I've given from the figure. This figure I will show later. So from the figure, I already can see the section current in section D is always less than the current section CD and likewise. So problem is there something, this is your D point, and suppose this is your BD and this is your E point. So the current will be here and here and here will be decreasing. Least current will be here, maximum current will be here. Similar, maximum voltage will be here and least voltage will be here. Because already we are giving some sections, and that if I'm increasing the section number of sections, voltage drop is going increased. Clear, so of course voltage at successfully that will be decreasing for the entry point. So you can see the figure already has said that what is the point I'm discussing. So you can see this your VA point that already just discussed. So if I'm providing some current I1 plus I2 plus I3, so I3 you can see this is the least current. Clear. Here I'm providing I2 plus I3. Here I'm providing I1 plus I2. Clear. So this current is of course decreasing. If I'm finding this is the highest current, this is the lowest current, this is the lowest current, and this is called highest as compared to this one or lowest as compared to the first one. Now, of course, the voltage, if I'm talking the voltage at point this VV, BC and BD, so of course BV is less as compared to BA, but will be greater than as compared to BC and VD. Similar, VC will be less as compared to BV, and that is called clear. So point you can say ultimately, so the you can understand that what I'm trying to speak here. First of all, whenever I'm increasing the number of sections, voltage drop will be increasing, and that current and voltage at each point of distance side will be decreasing. Clear. So how can you solve the circuit? How can you solve the problem? First of all, we have to find number one, resistance of each section. Number two, we have to find current of each section. Number three, we have to find voltage drop of each section, and number 4 point, we have to find voltage at each point. So hopefully you've got my point. So number one, we have to find the distance of each section. Number two, we have to find current of each section. Number three, we have to find voltage drop, that is the multiply of 1 and 2. We'll get number 3. And number 4, we have to find voltage at each point. Clear, by subtracting the main voltage minus voltage drops of the section voltage. Clear. So this time I will solve the numerical so that you will get more answers. Clear. Now what is the meaning of distributor fed at both end? What is the meaning of that? Both end already I've said. Both end means we're having two end, starting end, that is called a starting point, and that is called last point for the consumer side. So we are having two voltage, that is called BA and BB. So in this type, the distributor is connected to supply. Now what is the advantage of the system? Now if I am talking about the feeding voltage at one point, clear, and tapping of consumers from this point. So of course, if we are feeding voltage at only one point, if there is any fault in this section, listen. So if there is any fault in this section, the point that is called point B, C, and D is not getting any power. Are you getting my point? If there is if I'm talking about the feeding at one point, if there is any fault at this point, clear. So B, C, and D are not getting any power. If fault is at this point, so only B is getting power, C and D not getting the power. So this is the disadvantage of feeding at one end. But if I'm talking about the feeding at both end, you can see it's your VA, its voltage at B point, so BV, and it's your BA. Now what's going on? Now we are having some section. Now listen carefully. It's very good point for all of you. So now again we are having some point that is called C, D, E. Now if voltage coming at this point, still C, D, E, all three consumers are getting some power from this end. If voltage getting from here, so at this time C is getting power from A, clear, while D and E is getting power from B. If voltage here, again CD can get power from A and E can get from power B. So ultimately interruptions of supply voltage will not be happening in feeding from both ends. So this is very advantage point, or we can say it is very good advantage compared to the feeding from one end, because if there is any fault in the system anywhere if there is any fault until all consumers are getting the point, all consumers are getting some terminal voltage from the both end. But from one end, if there is any fault, so what is the nearby consumer of that line? They are getting supply, but the far consumer, that is called, if I'm talking, we can say if your fault is occurring between B and C. So of course, D and E are not getting any power, while V is getting power. So this is very, very disadvantage of the first one, that is called feeding at one point. But if I'm talking about the feeding at both point, you can see in this type of distributor is connected to the supply both ends, and voltage at feeding points may or may not be equal. Of course, that depends on the conditions. Means both points, both feeding voltage must be equal or must not be equal. It's not a minimum criteria. The minimum voltage occurs at the sum load point, which is shifted with the variation of load on the different sections of distributor. If a fault occurs at any feeding point, continuity of supply is ensured from the other feeding point. This is very, very advantage point for the second, that is called feeding from both ends. If a fault occurs in any sections of distributor, continuity of supply is ensured on both sides of the fault with respect to feeding points. So just I'm giving some example. You can see clear the first numerical that I'm giving here. That is called question number 1. You can say clear. So what they have given some, that is the current, that you can say 500 ampere, 400 ampere, 250 ampere, 50 ampere, and these you can see, understand. I think so everyone can understand. Clear. So this is the section current. This is the section. We can say 500 meter, 500 meter, 600 meter. There's a, we have given some distance. Clear. Now suppose just I am saying that resistance of this feeder per kilometer is 0.02 ohm per kilometer. That's the resistance. So how can you find the voltage at each point? I have given the distance of the section that you can see 500 meter, 500 meter, 600 meter, 400 meter. So ultimately the line length is 2 kilometer, total length of line of 2 kilometer. I am giving the resistance 0.02 ohm per kilometer. Now give me the value of voltage at each point. I want voltage from BB, that is called BB, BE, BC, and BD. How will you find? Tell me. Next, are you getting my question? What I'm asking you? Nasro, are you getting my question? Nasro, I'm asking you. Nasro, are you listening me? Actually, it's not here. Nasro, you are here, but you are not replying. Are you here, Nasro? Nasro, I will not mark your attendance. Keep in mind if you're not replying. Only time is going on. That's I'm asking. Nasro, unmute yourself and speak here or write in the chat box, whatever. If you're not replying, I will not mark your attendance. Keep in mind, I will mark absent because such lectures I will not provide. Only I am speaking, only one person is here, or is speaking instead of that person. I am speaking here. I'm trying to teach, but you are not giving any response. Okay, so this is the last call, else I will end the meeting now. Nasro, are you listening me? Okay, this numerical already done from my side. I will not repeat this numerical again. Okay, so just I'm ending the meeting now. This was the last call. I'm asking to you, can you reply in the chat box or either unmute yourself and speak here? Okay, so I'm just ending the session now.